Hello, everybody. Welcome to this webinar. I'm really happy to have so many people already connected and hope that many others will also join. This is the last webinar organized by the HACID project. The HACID project is a European project that aims at studying hybrid collective intelligence in different professional domains. And today we look into medical diagnostics, the healthcare domain, and beyond. The webinar is hosted by HumanDx, and we have Joelle here who will moderate the discussion. Thanks for your participation.
Thanks, Vito. I can take it from here. Hello. Let's first introduce who Vito is. Vito, he is a researcher at the CNR. He's the coordinator of the HACID project. And I am Giada Barabucci, a professor at the University of Cologne, research head for HumanDx. And HumanDx is one of the partners of the HACID consortium. So first, a word of introduction on HumanDx. HumanDx is an online collective intelligence platform for health questions and above, as well as a community of medical experts that provide insights altogether on these medical issues. So before we start, I would like to thank Vito for the organization. I would like to thank the speakers for being here and all the attendees for, I hope, sticking to us until the end. I will start now sharing our slide deck. And we can start with today's plan. So what's the plan? We will start with a brief introduction to the term and the field of collective intelligence. Then we will go into 3 short presentations. The first one on the past accomplishments of collective intelligence, in particular in the medical field. And then we will have an overview on current bleeding edge research happening inside and outside the HACID project. And last, an overview of what the future holds for this field. Questions? At the end, there will be a Q&A session in which all speakers will address your questions. Please, if you have any questions, write them down in the meeting chat. That's the first button on the top. Feel free to write questions anytime, and I will collect all your questions and do my best to organize them in a coherent form for this last Q&A part of the webinar. I will also interrupt the speakers in case there are some questions that require an explanation on the spot. With that said, we can start. We can start with the overview of the field of collective intelligence. Jay Komarnen, who is the CEO and founder of HumanDx, will briefly introduce us to the many facets of collective intelligence. Jay has founded the HumanDx after a career in alternative investment funds and consulting firms. So his experience with collective intelligence goes, let's say, way beyond its use in the medical firm. Please, Jay.
Yes, thanks so much, Vito. The term collective intelligence is quite broad. It really refers to the aggregation or agglomeration of intelligent agents to more effectively solve some problem together than apart. And, there are many terms that you may have heard in the literature that connect to collective intelligence. Everything from mixture of experts, multi-agent systems, blockchains themselves, which use distributed machine validation, ensemble approaches, federated learning. There is quite a variety of different ways of thinking about collective intelligence, even as it pertains to technology. But it's also a much broader concept. If we really think about, even from a biological perspective and a systems perspective, collective intelligence is functionally why our whole body can perform quite differently than an individual cell. And the intriguing part of most aspects of collective intelligence is that scale is not the only driver of collective intelligence. Diversity, the breadth of capabilities or capacities of such systems is also tremendously important to these kinds of systems. And as we kind of move towards a future of AI that integrates human intelligence more fully, we're very intrigued by the potential of the complementarity of these systems with human expertise and the ability to collaborate and coordinate humans at scale to solve much more complex problems than has ever been possible. Next slide, please.
Sorry, we have a video rather than a slide. So.
Oh, right. Yes, that's correct. I think we put together a very brief video to show you how the software in the platform today works. But I'm not sure. Are we having trouble loading that, or is that playing now?
You would see the video in a second.
Okay. Well, if we're having ongoing issues, we can always circulate it at the end as well. It's really up to you, Vito. And Joey.
The video?
I am not, but if others are, please chime in.
Oh, okay.
I don't think. Yeah. I guess
okay, sorry. I was looking at the video, so maybe there's a problem.
Okay.
Yeah, we can share, we can maybe share a link to it in the chat. So.
Yeah, that sounds good. We can share it later. Okay. Yeah. If you want to go to the next page, and we can continue. Great. Are we about to go into the first section, or do you want me to provide additional context here?
I think before going into the next session, you can talk about the things you would have been talking over the video, please.
Sure. Yes, absolutely. So as we kind of built the Human Diagnosis Project, or Human DX for short, the first thing we became interested in was, could you combine the perspectives of many professionals in medicine to provide better perspective than any individual professional? And this is something that's not uncommon in medicine already. Of course, there are peer review processes. There's kind of grand rounds, M&M conferences. There's many ways of sharing knowledge as well as case-based learning. And so our thinking was, could you use this case-based learning process to actually not only help physicians learn and train and improve their clinical reasoning, but could you actually use it to produce more intelligent systems? And so where we started actually was looking at how you could take the perspectives of many humans and combine them together to produce better answers using artificial intelligence methods, including natural language processing, text extraction, medical ontologies, other things that predated LLMs. And the intriguing results of those research was that even human collectives alone can vastly outperform individual medical professionals. And I think, are we starting the first section then? Or is there anything else you wanted me to provide in context there?
Thanks, Jay. We can slide into the next section with
okay, perfect. Great.
So thanks again, Jay. We will hear from Jay once again soon. He will be presenting later today about the future of collective intelligence. But let's go in order. Our next section is about the past of collective intelligence, how we got here. Eugene Chu will introduce us to the research done in the past decade that shows how effective collective intelligence methods can be in generating insights that are comparable in quality to those of top experts. Eugene is a clinical assistant professor of surgery at the University of California, Irvine, and senior medical advisor at HumanDx. Those are just two of many Eugene's qualifications. In particular, what's relevant for us today is his role as a physician director of telehealth and technology integration at Kaiser Permanente, the largest managed care institution in the USA. So please, Eugene.
Thanks, Yole. All right, I think I'm going to take a little backpedal because our video didn't work, just to provide a little bit more context. And I think that'll be helpful for the couple of slides I'm going over. So what you will see in the video, hopefully when you get to watch it later, is the Human DX platform in action. And so you can imagine, let's say I'm a patient and I have a question. I could pose that into the platform and immediately get a response, an AI-based response. Okay, so that's what Jay commented about, looking at different LLMs. But then there's also a human component, right? So asynchronously, that same question that I had posed to the system will go out to other clinician human DX users, and they have the potential to weigh in. And then their responses get collated and aggregated, and that can be part of the answer that's provided to the patient. So just wanted to provide a little bit more of that context. So what I will be talking about is really focusing on the individual, so focusing on the human, so to speak. So our first step in this journey was to establish some objective, scalable measure of clinical performance, what we call quotient. So the parameters that we defined were diagnostic accuracy. So did they get the diagnosis right? Breadth, so how many different potential diagnoses did they consider? Efficiency, how quickly did they come to the correct diagnoses as different clinical clues were reviewed on the platform? And then speed. So we built a machine learning model to evaluate this individual performance. And with a data set of 11,000 unique solves on the system, done by 1,700 physicians, we basically demonstrated that we could quantitatively and scalably measure diagnostic performance on our system. Next slide, please. All right. So here we wanted to model group diagnostic decision making. So we created collectives of physicians. In this case, we took 2,000 doctors, put them into variable size groups, and had them solve, and the group solved a total of 1,500 cases. So I'll turn your attention over to the graph on the right. So on the y-axis, we can see diagnostic accuracy. And then in the x-axis, it is the number of solvers, the number of individuals within a group. Okay, so if we just focus on the individual, right? So 1 on the x-axis, you could see their diagnostic accuracy was 62.5%. So better than a coin toss, but not that much better than a coin toss. As soon as you add one person, you can see it already increases pretty significantly. And the increases continue as you add more and more people, peaking out at around 9 individuals, right? Where accuracy was 85.6% versus 62.5% for a single individual. The results were robust and held up across different physician specialty, whether you were a head and neck surgeon like myself or a general practitioner, training level, geography, all the results continued across that. So some things you would expect. So if you look at the graph, when you exclude trainees, so no students, that's the yellow-orange, you can see the performance is better than if you have only students, which is the darkest line along the bottom. What was a little unexpected and was not demonstrated in this graph is that if you took an individual specialist, so an individual head and neck surgeon, and compared it to the collective output of, let's say, general practitioners, they actually outperformed the individual specialists. So something to keep in mind for our later discussion. Okay, we can go ahead and advance the slide, please. Okay, so in the last slide, we grouped the different clinicians without regard to their clinical quotient. So a higher clinical quotient implies a more skilled physician. So in this graph, which I'll go over in more detail, we considered not only weighting by the position of the diagnosis, but also by the individual quotient of the clinicians within the group. Okay, so same thing on these graphs here. So y-axis is diagnostic accuracy, and then along the x-axis is the collective size or the group size. So the non-quotient weighted groups is the smaller embedded graph, and then the quotient weighted group is the larger graph. So you can see with both, as the top 5 diagnoses are considered instead of the single top diagnoses, you get better performance. Okay, but when you look at the quotient weighted group, which again is the larger graph, you can see that accuracy can actually approach very close to 100%, as opposed to with the non-quotient group, it was, in the 80s to 90s, depending on how many people you have in that group. All right, so let's advance to my final slide. Okay, so what does this all mean in practical terms? Well, one thing is for sure, we can't always choose the best doctor. We probably don't even know who the best clinician is for our particular problem, right? But we do know that collective intelligence has the potential to reduce diagnostic errors simply by improving accuracy. It also highlights the fact that collaboration outperforms isolation. So the benefits of geographic proximity to other physicians that you might see in an academic medical center or a multi-specialty group practice could be extended now to all settings. We demonstrated bridging of specialty gaps. That is, again, the example where a generalist, so someone without specific subspecialty knowledge, as part of a collective can outperform an individual specialist. And I think one of the key aspects is scalability and efficiency. So there is the potential now to democratize access to the highest quality of care at a lower cost, with particular implications, of course, for resource limited contexts. All right. Thank you, Jolie. I think it's back to you now.
Thanks, Eugene. We now move on from these examples of a solid established research to the more bleeding edge research in collective intelligence, in particular to research in hybrid human machine or human AI collective intelligence. Julian Berger?
I'll just mention one brief note, Jolie, before you continue, which
Please.
is the very natural progression of our research after kind of looking at how AI could be used to synthesize different individual human professionals into a single answer. As LLMs and foundation models came on the scene, we became very intrigued with the idea of applying those same approaches to AI models. So if you queried AI models independently and synthesized them into a singular answer and or combined AI models with human experts, those were kind of the next natural steps from our original research. Now we can turn it over to Julian.
Thanks, Jay. I believe Julian will also introduce that point or going more in depth on that point. Julian Berger is a postdoc fellow at the Max Planck Institute for Human Development, an institute of the Max Planck Society. That's the National Research Institution of Germany, as well as a partner in the HACID project. So thanks, Julian. Please.
Yes, pleasure to be here. Thanks for having me. So before I turn to my own research, I'll give some background on where we're currently standing with machine collective intelligence, hybrid collective intelligence, right? Building up on what Jay was just saying, right? So what happens if we apply the same approaches to machines in general and LLMs more specifically, human DX data, right? And this is what we're seeing here. So these results are based on a human DX publication in the New England Journal of Medicine AI, where the answer really was, we can use different models and query different models to get us an answer, a differential diagnosis, the same way we ask these differential diagnoses from humans. And what their research really nicely demonstrates is that we do find, this collective intelligence effect of aggregating the independent differential by many humans. This effect also applies to AI models. So here on the x-axis, you have different models such as Cohere Command or Google Palm and Llama. And the thick line, right, the colored line is basically the average accuracy over a couple of these human DX cases that the models can solve on their own. And as soon as you start adding not just one model, but two models, your accuracy grows. And this, then finally comes to the top and best accuracy of combining 4 LLMs. And this combination of 4 LLMs then again is better than the best performing single LLM. So next slide, please. We then went on and continued the same approach of using not just LLMs, but also humans, okay? So in this very sweet work that Nicholas Zeller, who's also in the HACID project here at the Max Planck Institute for Human Development, demonstrated is that you do get a benefit from not just using AI, but also using humans, yeah? Or you can also put it the way around. Putting more LLMs into human-only groups improves performance. And so if you kind of squint here at this top graph, we see on the x-axis the number of physicians included into one of these hybrid groups, whereas the 0 means we only aggregate multiple LLMs. 1 means, we put 1 humans in combination with potentially several LLMs. What we find here is that typically these models that we use, and these are also now newer models, right? So we have ChatGPT-4 in here. They on average outperform the average physician, but as soon as you start combining them, right, you quickly outperform the average physician with also these average models. And this comes to its pinnacle if you start combining multiple humans with multiple LLMs, you get the top performance. So you find, so this way of combining AI and humans achieves the sweet spot of complementarity, where the combination of humans and AI are better than the best performing part on their own, meaning they are better, the hybrid conformation is better than just humans or just AI. And the reason for this is really that, these errors are complementary. So, if you start aggregating, you do see that whatever is, models and humans might disagree on what's incorrect, but they did agree in the, in the limit to what's being correct. So we're aggregating basically, evidence in favor of the correct option. Now you can advance the slide, Joella. And this is really different from what we see most of the time, which is really also the science with AI from the past, and now again in a different ways with LLMs that we use large language models and then AI more generally as these advisors. Okay, so what happens is you're a physician, you're diagnosing a case. Here in this instance, right, you're looking potentially at an image of a skin lesion, and you have to decide whether this is a cancerous lesion or not. And during your own decision making, you might be already advised by some model that's potentially also really good at this to say, I think this is a cancer case, this is a melanoma, and I'm sure with a 90% likelihood. And then the human is tasked to integrate this information into their own decision making. What sometimes also happens is, you make up your own mind and then you go to ChatGPT and ask for a second opinion, and then again you have to integrate. So AI most of the time is used as this advisor setting. And in my own research, I compare how using this AI as advisor approach compares with aggregating independent choices by humans and machines. And now please advance the slide, Joella. The simplest form that we come up with to really bring it down to the basics is what we call the hybrid conformation tree. And this is inspired by how in Europe, typically mammography screening works, okay? In Europe, mammography screening in most countries works in that way that you get 2 independent radiologists to look at the mammograms. And whenever they disagree, right, there's some tie-breaking mechanism that then determines whether the patient is being recalled or then asked to be or invited again 2 years later down the road. So this is a very nice example where in the real world we rely on the wisdom of crowds, of human-only crowds, to get a greater accuracy. What we are proposing in its essence is to replace one of these two radiologists by an AI model, okay? And we're saying we get a human first, ask their opinion, right? This is kind of branching out at the top from this first human, and then we get an AI model. And whenever they agree, we stop. We don't consult any more agents, whether human or AI. We simply accept the answer because we say this agreement is a proxy for accuracy. If whenever they disagree, so this is kind of at the second stage, looking at these little robots, when they disagree, we get a second human tiebreaker in to be the final deciding factor in what action to pursue. This is a really, really simple strategy, right? You can kind of memorize it as whenever human AI disagree, we get a second human. Yeah. And what we now can do is if we have data on humans that were advised by AI, right, and basically a control group from experiments, we can simulate how this hybrid confirmation tree, right, this mammography equivalent with an AI would perform as compared to humans that receive the same AI decisions just as advice. And now please to continue. So what's cool is that we can test this not just in medicine, but also different domains in general. Okay, so what we did is we took pre-published data from different disciplines, different journals, different outlets, computer science, psychology, and so on, and looked at all these nice experiments where people gave some form of AI advice to one treatment group. And you find these 10 different data sets on different problems on the x-axis. So we're looking at finding the correct sentiment in beer reviews, for instance. We have colonoscopy lesions that were done both by experts and by less experienced, non-expert participants, where they had to evaluate whether there was a lesion present in a colonoscopy video. We can look at headlines. So somewhat in the middle, this is people that were advised by ChatGPT whether a headline contained the true or false news, right? And for instance, we can also look at deepfakes. So whether humans and AI recognize that a video was edited as a deepfake or not, okay? So it's really nice to show that this works in different domains. So how does it work? Okay, so if you check so higher on the y-axis, this means higher accuracy, and we compare humans alone, that's the orange dot, with humans being advised by AI models, okay, that's the red dot. And then we can compute the hybrid confirmation tree, which is this tree process that I just showed on the previous slide. And if we compare this, we do see that on average, the AI advice helps humans in their accuracy. They're getting better by receiving AI advice. However, instead of giving AI advice, relying on the wisdom of hybrid crowds with the hybrid confirmation tree improves accuracy further. Okay, so like these numbers at the top, is the increase of the hybrid confirmation tree over using AI as an advisor. So I think this really nicely demonstrates that across a wide variety of decision-making problems, beyond medicine even, with different AI models, which can be simple classifiers, but also a large language model in the case with the headlines here, we do find that there's a really good benefit from relying on the hybrid of wisdom of hybrid crowds. And I've a ton of research on this. If you want, I have two manuscripts. I'm very happy to talk about this, but I'll stop here and go to basically the takeaways, which are, right? So we think that relying on collective intelligence, hybrid collective intelligence, really helps us avoid these AI errors, okay? LLMs are prone to hallucinations, meaning incorrect output, that they are somewhat confident in, so they respond this to you. Humans do, on average flag these things, so aggregating with many humans, increases your chance to overruling this incorrect AI output, which is also true for, biases that pop up in large language model training, right? So again, this ensemble effect from relying on human intelligence to overrule incorrect AI really helps us out here. And this also helps us, override incorrect model responses if they, if you use a model in a different context. And what we really nicely saw in Nicholas' paper is that, these inconsistent and unstable responses by many AIs, this inconsistency shrinks as soon as you start aggregating from many models and many humans. And the fact that we can rely not just on one model, but many, right? And they're somewhat interchangeable. And it's actually good that they're interchangeable, so their hours are uncorrelated, means that this hybrid effectiveness, can come up with not just relying on one model or OpenAI or Google and whatnot, but we can use different models at different times. So we're not necessarily buying into just like one provider and one system to get at these benefits. So this is me. Happy to take questions later, but I think I'm giving back to Jay.
Thanks, Julian, for the great overview. And indeed, we are going back to Jay. For
thank you.
The overview of the future.
Yeah, thanks so much. That was a really helpful section from both of you. So I think what's very intriguing is that we're kind of at the very cusp of this research, really kind of coming to a very kind of exciting and interesting progression. Basically, today, as many of us are aware, most of the research being done is primarily on the results of AI models alone. And as we kind of continue to see more models emerge, including specialized models, agents based on AI models, there is going to be a large scale and diversity of agents, both human, machine, and organization, that can produce greater results than any individual agent alone. You can go to the next slide. So some very intriguing areas that we want to explore next. And Julian's research kind of begins to explore some of this, but in particular, we want to continue to show that the results that we're seeing here transfer and generalize across most knowledge domains. And based on our kind of internal testing and research, that is currently our strong hypothesis. But of course, formalizing that in the literature will be something that we're very interested in. The second piece has a lot to do with how to best use human and AI in concert. As we talked about, one very intriguing aspect of the research is that independent collectives, so where humans and machines are taken as independent inputs as opposed to having humans consult AIs before combining their answers into such a system, actually produce better results. But I think we're very much at the nascency of all of the potential ways that you could have human and AI models interact to produce better results than either alone. So I think there's some very exciting and intriguing things to do there. And I think the third point relates to that in terms of the actual way that we design systems and experiences to enable those types of processes. I think that, another piece that really is important that's coming out of this research is ensuring that this type of research can transfer to real world settings. We did some of that research with human-only collectives with a clinical trial at UCSF, which showed some pretty surprisingly powerful results to changing people's diagnostic answers and also giving them confidence in their care plans. So I think that continuing to see that this research doesn't just apply to kind of gold standard cases with known true answers, but actually in open-ended live settings is something that we're very excited about continuing to explore as well. We can continue. So one of the reasons that this problem is so urgent right now is because I think that, if you look at the data around people's comfort with the way that foundation models are being developed, AI systems are being developed, humans and society in a large way are being left behind. Basically, none of us at least have a seat at the table. Basically, very large monolithic systems controlled by private companies, individual shareholders, and in some cases, potentially even countries, are the ones that this value will be rapidly accruing to. And trusting those systems in a way that ensures that they are not biased, that they're not using information that may be concerning, is something that we don't have the potential to really solve right now. As we already discussed, and Julian discussed in some detail, we're seeing that these models have many errors, biases, errors, hallucinations that can be improved by looking at where the models converge or diverge. When you see that the models converge, you can have more confidence, if not certainty, that the answers are correct, particularly if they converge with people who are leading in those given fields. But when you see the answers diverge, that is a clue that there may be a possibility of biases, errors, and hallucinations. Because we, as human participants who have expertise in various knowledge domains, also improve these systems, there is the value and purpose of people contributing these systems actually being rewarded for their efforts. What we're currently seeing is the death of the public web. And the reason the public web is dying is because who wants to contribute information that makes Sam Altman and Elon Musk rich? Not really many people. I mean, I think that's not necessarily the most exciting way to spend one's time. So I think one of the things that we're very curious about is there a way to actually reward everyday people and people with expertise in a variety of areas for the value they contribute to such systems. And I think in a collective intelligence approach, you have the very intriguing possibility of both measuring that and apportioning value accordingly. We can continue. So one of the ideas that we've been considering, and that we're kind of, if you actually look at the video of the software, you can kind of get a sense of how the system works. The level of clarity or trustworthiness you would need in a specific answer depends on the situation. So for example, if you are just asking a very general question like, when did Napoleon die or something, that's not something that necessarily needs a lot of confidence or checking. Most systems that are of reasonable quality will have the correct answer to that question. But as you get into questions that have probabilistic, subjective, and/or qualitative aspects, the ability to have confirmation for high value and high uncertainty requests is very useful. So that could apply to law, medicine, finance, many other topics. But essentially, when there is high uncertainty and high value to a request, you may be interested in ensuring that you have the correct answer. That may be consulting more models. So instead of one model, many models, both foundation and specialized models in a specific field. And that may also be checking with experts in those fields that the model outputs are reliable and trustworthy. And because the research that we've done shows that as you construct these independent collectives where you actually take multiple models or agents and you combine that with human expertise, that's where I think you get to really potentially exciting results in terms of producing better answers than kind of individual models today can. And then I think the second piece of that that's really interesting is that collectively machine and human validated data can actually produce safer and more trustworthy models longer term, models which hopefully can be more communally owned as opposed to just owned by single stakeholders. Shall we continue? Thank you, perfect. So yeah, so this is just kind of a summary of some of the topics that I just mentioned and perhaps some of the things that we're excited about. We talked about the performance and trustworthiness benefits of collectives, both in terms of accuracy. The fact that independent agents are converging at an answer creates a level of clarity and trustworthiness versus perhaps, groupthink or the sense that maybe a single entity is controlling the answer that you're receiving, which as those systems become more under centralized control and continue to go in that direction, there can be more concerns about that. And then, of course, we mentioned that in all systems, diversity of intelligence plays a powerful role in coming to the correct answers. And that is very much shown in Julian's research and kind of Max Planck's research around human AI complementarity in terms of both answers and errors. The other benefit, I think, of having a system that has distributed intelligent agents providing answers is you can get to results that are also more secure, transparent, and in certain cases private. Your requests can be more private, and the answers that are stored for you can kind of remain more anonymized as a result of some of these decentralized technologies. And then lastly, I think where we're going and where we're really excited about is this idea of, is there a way not only to produce better answers through collective intelligence, but is there a way to give everyone a seat at the table from an economic and governance and safety standpoint? So I will pause there. I think that's kind of our final slide. Is that right, Jolie, or am I missing one more? Okay, perfect. Yeah.
Thanks, Jay. Thanks, Eugene, and thanks, Julian, for your presentations. I think that that was a very, very nice trip through collective intelligence from this human-only past to this hybridation with machines. I believe it's a bright future. Now, for the QA, we have some questions, and I think I would like to go more or less in the same order as the speaker posed them, because they make sense. Stefan Child, would you like to pose that question yourself, or should I just read it? That's a question also for the others. Okay, I see there is a technical issue here, so I will just read the question aloud. I must. So the question is, how real world the inputs are for the case used in validation? Can a patient directly enter data, or does all current research practice require a clinician to enter the data question? So I will say these are actually two different questions. First of all, what has been used as data for the studies that we have seen, and what is currently used and will be used? I'll take the first question, and I can tell you that all the results that you've seen until now, they are all based on cases that are real-world cases, however, entered by physicians, by medical people. That means they are well-structured and they contain proper terms. And then I think I will switch over to Jay to talk about the future. To talk about the current data that is more patient-oriented, maybe.
Yeah, and I should add that many of the cases used for the research came from vetted case reports from major universities, from the American College of Physicians, and other national physician bodies that were both peer-reviewed and vetted to kind of ensure that they were based on real-world evidence, and also that they had a definitive diagnostic outcome based on the electronic medical record. So that is worth being aware of. Can a patient directly, so the second question is, can a patient directly enter data, or does all current research practice? So to date, most and pretty much all of the usage of the product is for medical professionals and trainees. Where the system is going is one that will ultimately be able to be much more open to everyday users. And even beyond that, to go beyond medicine as well. So to actually enable the power of collective intelligence for any query or request, not just medical ones. But I think that's kind of where the system will start, and it will kind of go from patients eventually broadly to other stakeholders. And I think probably one interesting thing to be aware of is the intriguing thing about patients is obviously they're patients in the context of getting support from a medical perspective, but they also often will have areas of expertise in many other fields. Those could be law, finance, tax, many other kind of categories of knowledge that could provide value back to the medical community as well as to the system as a whole. Next question.
Thanks, Jay. I think I will leave Ursula's Hübner question for later because it's a very open-ended, not even question, but a discussion point. I will go to this quicker question by Dr. Simon Packham. If there is a European equivalent of the US Open Evidence app, do Eugene or Jay, Julian know of any EU-based equivalent?
I see there was a product, a link posted. Should I share that here? Is that helpful?
I think you can, Jay. So I'll just comment a little bit. So I'm in the US, and so I do use open evidence on occasion. I understand it's locked down because I think you need some US credentialing or licenses is what they look for. So in the background, we did a little bit of a Google search on this, and I think something that might have appeal to the EU is something called Dr. Oracle. So I have not tried it, but I understand it's open to a wider variety. US, UK, and EU. So that might be something that could be helpful.
Yeah, and also to add the Iatro and IatroX platforms, they are UK-based and based on UK guidelines. It's a sort of fancy search engine for everything that counts as a science in the UK. If we want to still count the UK as EU, we can think of it as a European equivalent of that, perhaps.
Great. I think Dr. Oracle, as the name suggests, is more medically related medical research tool. So maybe more in line with open evidence, I would say.
Okay, thanks. Then perhaps Ursula, can you unmute yourself to perhaps tell us quickly about this paper you just referred us to? If that's possible.
Oops, sorry, I missed that. Did you have a question for me regarding cost?
Not at the moment.
Okay.
I'm trying to H. Okay,
yeah. So well, while we're waiting for Ursula, we
Ursula
can. I guess we could. Okay. Well, we could always, come back to that if it's interesting to anyone else. But I think the challenge with some of these questions is it depends on the domain, it depends on the context, and it depends on how established the domain is, how much training data it has, many other factors. It's too easy to say that kind of one systematically always outperforms something else. And even in the case where that is the case, which is I think one very intriguing part of the research, there is still additional incremental value to collective of human intelligence integrated with machine intelligence. So I think one of the very intriguing aspects of Max Planck's research was that even where a human expert is universally outperformed by a model, it's the professional still adds value to the collective. Should we go to the next question?
Yeah. So the next question is, I can summarize Asim Sharef's question is, for people that would like to go into the AI field coming from the medical professional medical side, which suggestions are there? What could be done? What are interesting possible fields, open fields, and open research questions For example, training a transformer model on a medical data, medical literature. Is that a worthwhile idea?
I can take a stab at this one, but I think maybe others in the group might be better equipped to answer the question as it relates to publishing. But in terms of just practical experience as a clinician, I can comment a little bit about how I use AI in my own day-to-day job. So I think it is a worthwhile endeavor to get your hands dirty, so to speak, right? Even if what you produce isn't something that goes into clinical practice or necessarily gets published, I think that experience, in my opinion, is worthwhile, because pretty soon I think AI is going to be embedded in all of our workflows, right? And so having some deeper level of understanding would be helpful. So I will share, I don't code, I don't know Python. I have some working knowledge of how AI works. And so like me as a department head, I created an agent to help with scheduling, right? Just using Microsoft Copilot, right? So very basic, just with prompting, right? Basically, so for that practical use case, it's taking referrals that come to my department. It's reading through the referral, capturing some relevant information on the reason for the visit, the chief complaint, puts it through my agent, which is looking at guidelines that I created. And the output is, it should see this particular doctor, or they should see this particular doctor, and it gives some level of urgency. So real basic, nothing too complicated. I'm not looking to publish it, but has practical value for my department, just as an example. But I would encourage others in our group to weigh in, maybe regarding the publishing aspect of it.
Thanks, Eugene. And while we are on the topic, there is a question that is probably addressed to you. If you are aware of a ambient transcription service that reverse engineers, so teach doctors about what questions were not asked during the clinical encounter, as a sort of
that is a
teaching help.
good question. Good question. I'm not aware of that. So it happens that for Kaiser Permanente, I led the deployment of our ambient AI scribe system. So that is deployed now to about 6,000 doctors. We've done over 5 million AI assisted notes. And so the AI is basically like a scribe, a very good scribe. So it listens to the clinical conversation and then outputs a draft note, including physical exam, really everything. And it's getting smarter and smarter to start suggesting potential diagnoses based on the conversation. We'll start to place pending orders, but it is not at this point being used as feedback for things that you had missed, but I don't see why it couldn't get there. So for example, in our organization, which is probably different than EU, before coming into a patient's room in the near future, I will see a list of diagnoses that are already in the system that I should review, refresh, and update. And the system can keep track for me whether I discussed those diagnoses or not. So if I talked about their hypertension, I'll see a little green check off on the list of things I need to discuss. And maybe I didn't get to their atherosclerosis of the aorta. That will remain as something I didn't look at. So very rudimentary. A physician leader could on the background look at Jay, let's say like, ooh, he only diagnosed or commented on 50% of the potential diagnoses he should have looked at as a general practitioner. So that is one area. We're doing ongoing research looking at notes done with AI assistance versus general clinician notes. Vastly different in terms of the level of detail. And so there is some quality and training implications related to that. But your question is a great one.
There's also some very intriguing results around what you just said, Eugene, and from the standpoint of in certain fields, some of the early research is showing that the reliance on some of these systems can actually make people worse at diagnosing or recognizing features, which is a very intriguing and challenging problem to solve, because there's obviously tremendous value in these systems, but then the over-reliance on such systems can actually degrade performance of individual professionals. So that's kind of also, I think, where Julian's points about independent collectives are very exciting, because is there a way to kind of ensure and kind of cultivate the quality of someone being able to have a perspective on their own, but then also be able to catch the issues that arise without having the system so integrated that their own skills decline.
Really good point. It's kind of unique now. We just take our system. Most of the clinicians kind of grew up in a world where they didn't have ambient AI scribes, right? So this is coming later in their training. But we also have a medical school, and for that we're very cognizant. So we don't want the medical students using AI scribes right off the bat, or even residents. So these are trainees further along, but not quite completely trained to get that experience. Kind of like, when you give someone a calculator, right? You want them to understand some of the fundamentals and basics. So what I alluded to before, currently, it's not at the point where it's going to completely suggest the diagnosis de novo. It's listening to the conversation and hearing. I might call out, you have a neck mass, and it's going to call it cervical lymphadenopathy. So it uses maybe a better term. But the future state, I know someone mentioned open evidence, right? So there is Open Evidence Visit, which is an AI scribe system made by Open Evidence. There's an agent there that will actively suggest, let's say, treatment recommendations or imaging recommendations, things that you didn't necessarily call out, but it's making active suggestions. So that has direct relevance, Jay, to what you were saying. If you become over-reliant on some agent making suggested recommendations for you, you're not doing that on your own, right? As opposed to now, it's more just kind of capturing and synthesizing what you're already saying. But the near future will be very different.
Thanks, both of you. I'd like to go back to Julian for perhaps our last question. Do you have any estimates of any kinds of cost savings that can be achieved using all these different hybrid methods?
Yeah, I mean, I can directly speak to, our proposal with this very simple process of the hybrid confirmation tree. Just like to comment also on the previous point of this issue of de-skilling professionals over time, right? I think that with our current work on hybrid collectives, right? So we inherently really want humans to contribute to this process, right? And we do need independent judgment, so humans can't really delegate their problem solving away, right? And just blindly rely on models, but we do need them in the system for this whole process to start. So as for cost saving is really, I think, depends on, what you're looking at. So our results show that compared to relying on humans or human-only collectives, we save, across different data sets, again, anywhere between, 25 and 45% of human consultations, while increasing the accuracy, right? So what we can model with math, but we can show this then in the data too, is that as long as machines are better than humans, we will save cost while increasing accuracy. If machines on average are as good as humans, we're maintaining the accuracy of human crowds while saving humans, okay? So if you compare our approach with the more frequent AI as advisor, it, I think, depends on, what is the cost driver of your whole system, okay? Because like if you look at mammogram readings in Germany, that I can speak to, right? These folks diagnose one set of images in, let's say, a minute, okay? So like asking a second opinion might just cost 1 minute of a very, specialized professional, but still it's, it doesn't take up hours. So if labor cost, so to say, is not your main issue, then the increase in accuracy that we're getting from the hybrid confirmation tree might reduce the errors that are actually really costly, which is sending healthy patients home and really missing their disease. Okay, so I think you have to look where the cost of the whole system is coming from. But in terms of labor costs, compared to human only options, it's big savings for sure.
Okay, thanks. We are at the end, so I will, in 30 seconds, answer a last question that is, if you use a human and AI, how do you select the right AI model, LLM? I would say that according to our HACID research, you do not choose it. You choose an ensemble of them, many of them, and then you aggregate through collective intelligence the responses. This relieves you from choosing them, and you choose what you go with the opinion of the group instead of the AI model. And how do you validate its output accuracy? Just like you validated the accuracy of single people. So I would refer to you to the literature that we have on this measure called the quotient that Eugene highlighted at the beginning, in which different dimensions of solvers of people giving answers are evaluated. So we are
on that first point,
please,
I just want to mention one last thing there, which is as kind of we continue to build this system out and have potentially highly specialized models for specific topics, the algorithmic routing of a request based on the features of that request will become an active area of research and technology development. That is something that we're thinking about pretty seriously, and also how to algorithmically assess how many models or agents are needed to actually provide a validated, trustworthy response based on how the answers converge and diverge, as well as the complexity of the request. If the request seems to be objective and deterministic, obviously fewer agents are needed comparatively. So that's a very good question and something that we're trying to understand better.
Thanks, Jay, for the clarification and future plans. There are two outstanding questions, and I raised them, but however, we do not have any more minutes. So we're already 2 minutes over. I would like to thank again everybody, the speakers, organizers, and also the